The project investigation was that the largest building that we have at the garden for energy consumption is the International Plant Science Center, which is a vault that is our preservation vault for the 7 million plant specimens that we currently have at the garden. The biggest energy user in that building is the centrifugal chiller. So what we wanted to do was find a way to create an energy efficiency program for that chiller. So we did research and we found a company called Permafrost. And Permafrost is a very simple installation. It's an additive that goes right into the oil. So the refrigeration and the oil run together, and this Permafrost, which is a nanotechnology, rides with the oil. And what it does is it makes improvements in the internal structure of the copper tubing that's in the chiller. We did some investigation and we spoke with Permafrost, and they sent us out to a computer cloud out in New Jersey, and we took a look at their existing situation. So they had 4 1,000-ton chillers. And so they took one of the 1,000-ton chillers and they added the Permafrost to it, and they showed us the data prior and the data post of the installation. And subsequently, the installation showed a 24% increase in efficiency at that location. So we thought that this would be a good opportunity for us to use that here. We contacted Permafrost. We told them that we were interested. We got all the data together that was necessary, and we applied to the Excel program to see if we could utilize this and get the unit charged with the Permafrost and show a payback period that was reasonable for the installation. The procedure that we used was kind of unique because Permafrost is not a construction project, and it's a oil additive installation. So even though it seems like it's expensive for the size of the container, which was about 1 gallon per each unit, maybe 1.5 gallons per each unit, we have a 300-ton chiller. So what happened was the Permafrost company comes with highly trained, highly skilled engineers. So these engineers come to the garden and they attached to about 6 different sites on the chiller to see what the efficiency readings were. But before they added the Permafrost, what they did is they tuned the chiller to its ultimate capacity with their experience and knowledge. So subsequently, they made improvements in the chiller. They made improvements in the condenser water temperature. They made the unit run exactly the very best that it could. Then they added the Permafrost. It took about an hour for the oil to siphon into the oil chamber. They closed everything up, they took their equipment off, and they went away for a month. It takes 4 months for the Permafrost to actually work. So what's happening is the Permafrost, the nanotechnology, the very, very tiniest particles ride with the oil through the refrigeration cycle. They clean up the interior tubes because a refrigerant is by nature acidic, and so it tears up the interior of the copper pipe. So what this Permafrost does is it starts to bind to the copper pipe. It starts to smooth everything out so that the oil and the refrigerant is running in a free, smooth, clear. It's like if you were frying an egg on a pan without any butter. So what they're doing is they're adding all of the lubricant to make this work better. It takes a month for everything to bind into the internal systems. On a system like that, the copper tubing inside the heat exchanger could be almost a mile long. So this is all taking place as we're working. The 4 weeks goes by, a month later they come back and they attach the exact same devices to the exact same locations, to the same computer via Bluetooth. We witnessed the whole installation and we started to take the readings. The readings came back in very favorable, and that's why I'm here talking to you today. So the baseline energy consumption for a 300-ton chiller was 273 tons. The adjusted kilowatt baseline is 334 tons. It's 220.4 kilowatts. The adjusted baseline kilowatt hours is 211,584 kilowatt hours. And the revised cost to run baseline is $33,853. After we did the installation of Permafrost, the kW post on the 334 tons is 180.4 kilowatts. The annual kW is 173,184 kilowatt hours, and the annual cost at our adjusted rate of 16 cents is $27,709. So the savings of energy costs per year is $6,144, and the installation costs $24,000, and our return on investment, or our payback period, is 3.9 years. So this fell perfectly within the time, the requirements that we have for payback. And the good thing about Permafrost is it lasts for the life of the equipment. And the Excel program requires a payback period, and the 3.4 years or the 3.9 years shows that we fall within the optimum payback period that's required by the XL program. Also, another thing that's very beneficial is the equipment. Now that it has the permafrost in it, will always be charged with the permafrost. Even if for some reason we had to drop all the refrigerant, capture it, and then recharge, the permafrost stays on the laminar boundary of the pipe and will always be there. And what it does is it increases the efficiency of the equipment for its life, and it increases the longevity of the equipment. So we could get almost a 20% increase in the longevity of the equipment. Well, first of all, I'd like to thank the Department of Energy Management and the City University of New York for the programs that they have set up for us to be efficient here. Secondly, I'd like to thank the New York Botanical Garden, the Board of Directors, and the senior management at the garden for having faith in the engineering department by doing these installations. And of course, I'd like to thank the staff at the New York Botanical Garden and the efficiencies that they provided and the fact that we care. We're an environmental organization. We work all around the world, and the best thing that we can do is set an example right here at home by participating in these programs. My main takeaway from this project is the concept that there's new technologies that are available that can sometimes be very simple because the technology is so advanced. And many times I have the opportunity to reach out to companies and engineering firms that really are concerned about energy savings, they're concerned about the carbon emissions and greenhouse gases. And the company that I used also goes out and vets the contractors that it sends to me to interview. Subsequently, I've had other technologies that have been introduced to the garden. I've introduced those, submitted them in the Excel program, and many of those technologies have been used at the garden too, and those technologies are also assisting the garden in making improvements.